Welcome back, 7th grade. I'm going to talk today about the difference between theoretical probability and experimental probability. Big fancy math terms. Please write these on the next title. Make this the next title on the next free page in your math notebook. After you've done that, get that brain on, eyes on, ears on, close everything up. Give me your full concentration. All right, before we get to it, let's think about a quick probability game. I'm going to have you pause and possibly even do this, right? So I want you to imagine this. You're going to shuffle a deck of cards, and I'm going to turn over the top card, and I win the game if the card I see is a heart, any heart. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Queen, King of hearts, I win. If it's a spade, if it's a club, if it's a diamond, I don't win. Imagine that for me, right? I'm just going to shuffle, and I'm going to turn over the top card, and I win if it's a heart. So, first of all, how would you rate my chances of winning this game if I play one time? Pause and decide for yourself. Okay? Next, here's what I want you to do. If I played this game 4 times, how many times would you expect me to win? Pause now and decide for yourself. What if I played the game 40 times? How many times would you expect me to win? Pause and decide for yourself. What if I played 100 times? How many would you expect me to win? Pause and decide for yourself. Okay, here's what I want you to do. I want you, if you have one, I want you to get a deck of cards, and I'm going to have you play 8 times this game I just said, where you just draw a card, shuffle, draw a card. If it's a heart, you win. If it's a spade, a club, or a diamond, you lose. If you're going to play 8 times for me, how many times do you expect to win? Okay, so now I want you to do it. I want you to pause the video here, get a deck of cards if you have one, shuffle, draw, and do this 8 times, and I want you to record how many times you actually win the game. So pause now, do that. When you're all ready, unpause, and we'll get after it. All right, so now you're all warmed up. You've actually already thought about everything I'm going to teach you about today if you did that game. So today I want to teach you the difference between theoretical probability and experimental probability. But first, I need to remind you of something real quick. I need to remind you how to switch between fractions and decimals and percents. We did this earlier in 7th grade, but it's going to be important today. So we'll do that. So let's just say we talk a lot in probability about fractions, right? So, you know, for instance, if I have, like in this game, I think there were 4 ways to win the game, or 4 suits rather, diamonds, hearts, clubs, and spades, and one of them let you win. So let's just say we would say you had a 1 in 4 chance of winning. To change a fraction into a decimal, you divide the numerator by the denominator, 1 divided by 4. So typically we do that with a calculator. I'll do that now. It's quick. That's the fastest way to turn a fraction into a decimal. 1 divided by 4 is 25 hundredths. Looks like that. So that fraction is the same as that decimal, remember? And then decimals to percents. If you can say this, you can do the percent, right? We would pronounce this 25 hundredths is how we would pronounce that. That's in the hundredths place. So we would pronounce that 25 hundredths, which we could also write as a fraction 25 hundredths, just like we said it. And remember, percents are always out of 100. So if we can turn that into out of 100, then we've got that that's also 25%. Part out of 100 is a percent. That's also how you turn a decimal back into a fraction. So all those things are things we did earlier and things that are going to come up here today, going between fractions, decimals, percents. All right, so let's go to, let's talk about this game you just played. You win by drawing a heart card. Remember there's 4 suits. There's hearts, diamonds, in a deck of cards, spades, and clubs, right? So you win in this case if you draw a heart, 1 out of the 4. So theoretical probability, you'll notice it kind of has the word theory in it, just about, right? Theoretical probability is what we've already talked about. It's the probability that you expect. Before you played this game, I asked you a bunch of questions. How many times would you expect to win? How often would you expect to win this game? That's called theoretical probability. It's a theory because we haven't done it. We've just thought about it like a theory, right? So we already talked about this, right? There's one winning suit out of 4 possibilities. So you would expect to win this game 1 out of every 4 times you played. Right? So you have a 1/4 chance of winning this game, or you would expect to win it 1 out of every 4 times you played. We often also express probability as a decimal. We don't always write it as a fraction. Sometimes you're going to see it expressed as a decimal. So just like I showed you before, you would express that same probability by doing 1 divided by 4. That's how we turn a fraction into a decimal. And 1 divided by 4, I already did, is 25 hundredths. And we also frequently show probability as a percent as well. So in this case, 25 hundredths, we would pronounce 25 hundredths, which is 25 hundredths, 25 out of 100, which percents are always out of 100, as we learned in 6th grade and earlier this year. So you have a 25% chance of winning this game, or a 1 in 4 chance of winning this game, or a 25/100th chance of winning this game. Those are all ways to express the theoretical probability, which is the probability you expect to win. Experimental probability is a different thing. This is how many times did you actually win? What actually happened? There's a good chance that even though you expect to win 1 out of every 4 times, so if you played 8 times, I would have probably expected to win 2. That doesn't mean that's actually what happens necessarily. You might have actually won 2 times out of your 8 tries, or you might have actually won 1 time out of your 8 tries. You might have actually won 3 times out of your 8 tries. It depends on what happened when you actually played the game, right? So theoretical probability is what we expect to happen. Experimental probability is what actually happened when you played it. I don't know what your actual outcome was. You might have won 1, 2, 3, 4, 5. I don't know how many times you won, but you would express that the same way. I won 2/8 of the time, or 1/8 of the time. And you could, of course, also change that into a decimal or a fraction as well. So I won 12% of the time, or I won 25% of the time. So let's do another one. Let's write one down together. And this time I'll actually do the experimental probability instead of asking you to, so that you can see how it goes. So open up your math notebook now, and let's do a different game for our WeDo. So here it is. You can go ahead and pause now and write this down. And remember, your 3 choices for a WeDo are this. One is you can keep it paused, and if you already think you understand this, you can do it. And then you can unpause and just make sure that what I do works for you. You also can kind of work a little pause, work a little pause, work a little pause, work it with me. Or you can just wait, look, listen, think, concentrate, let me work the WeDo, and then you can write it down when I'm done. Whatever's best for you, what helps you remember, and what helps you feel the most confident. So we're going to do a different game here where you win if you land on any color except white on this spinner. So I'm going to spin this spinner. I'm going to, there's 8 different sections. There's one that's white. And we're going to spin that spinner and see how often we win. So before we do, let's talk about theoretical probability. And let's write this down. Theoretical probability is what you expect in this game. So if I look at this, there are 8 possible outcomes. 1, 2, 3, 4 at the top, 1, 2, 3, 4 at the bottom. There's 8 possible outcomes. So remember, probability is the number of winning outcomes over the number of total outcomes. So in this case, there's 8 possible outcomes I could land on. And we win on 7. Oop, didn't mean to spin it. We win on 7 of them here. So in theory, we would expect to win this 7 out of 8 times. We would expect to win this game 7 out of every 8 times. Let's see, let's turn that into a decimal. So to turn a fraction into a decimal, I would do 7 divided by 8. 7/8 is 7 divided by 8. A couple of choices when you do this. I'm not going to get a nice clean decimal. So you can either write the whole thing, or a lot of times, since we know we're going to go to a percent, you might want to just cut it off at 2 places. Either thing works. You might want to just say 87%, or you might want to use this 5 and round it up to 88, or you can write the whole thing. It's okay with me either. So depending on how you'd like to do that, you can just cut it off at 2 places, or you can round it to the nearest hundredth, or you can write the whole thing. I don't really think it's a big deal which of these methods you pick. They're all going to be super close. And then, of course, that's my chances of winning as a decimal. And then, of course, all these can be turned into a percent. So if you chose that one, that would be 87%, 87 hundredths, 87 out of 100. This would be 88%. And this one, a little tricky, would end up being, we'd move the decimal twice, it'd be 87.5%. All of these are fine. It wouldn't bother me whichever one of these you chose. So I would expect to win this game most of the time. It's pretty likely to win. I have an 87% chance of winning this game each time I play. And I would expect, in theory, to win it 7 out of 8 times. Experimental probability is what actually happened. So in order to do that, if I expect to win 7 out of 8 tries, I'm going to do 8 tries, let's just say. Since I expect to win 7 out of 8, I'm going to see how many times I win. I'm going to do it real fast. So I already spun once. I got blue, so that's I won once. All right, second time, win again. I won twice. Third time, won again, 3. Fourth time, won again, 4. Fifth time, won again. Sixth time, won again. Seventh time, won again. Eighth time, won again. So in this case, my theoretical probabilities, I did 8 tries and I won all 8. So my experimental probability, different than my theoretical probability, I actually won 8 out of 8 times, which of course is 100% of the time. So just because I expect to win 7 out of 8 times doesn't mean that there's a guarantee that that's exactly what's going to happen. I could have played, I could have won 6 times, I could have won 7, I could have won 8, I could have won 5. Who knows? But experimental probability is like what you get when you actually do it. So it's a different thing. They might match, they might not. Just depends on what happens. Y'all, that's the difference between theoretical and experimental probability. I hope this made lots of sense to you. If it didn't, I highly recommend just watch this video again. A lot of times going through something a second time makes it super clear. If you feel like you have this enough to start class tomorrow, I will see you then.